Hello, everyone. Today we're going to be talking about inductive reasoning. So earlier in the semester, we talked about deductive reasoning, reasoning about what must be true of a particular case based on a general principle. We talked about, for example, how you can tell whether a deductive argument is valid and whether a deductive argument is sound. In this section, though, we're talking about inductive reasoning, reasoning about what is probably true based on multiple premises, observations, and pieces of evidence. So with the deductive reasoning, we are trying to figure out what must be true of a certain case based on a general principle. One of the examples we looked at is if someone is a man, then that person is mortal. Socrates is a man, and therefore what can we conclude from these pieces of information? Well, what must be true based on those pieces of information is that Socrates is mortal. Inductive reasoning, however, is different. With inductive reasoning, we're gathering together information. So premises, observations, pieces of evidence, and the question is, what can we conclude based on this information? Now, sometimes you're going to be right, sometimes you're going to be wrong. This is why it's reasoning about what is probably true based on the information. But the question is, we've gathered this information. What's the best conclusion we can derive from this information? That's what inductive reasoning is. What I'm going to do now is show you a sample inductive argument. So you'll see a bunch of premises or facts, and what I want you to try to determine is what can we conclude based on this information. I'm not going to read them to you to help save my voice, but here's premise 1. Here's premise 2. And again, as you're reading them, try to figure out what can we conclude based on these premises. So if you had to come up with one statement to sort of summarize from all this information, what would it be? Okay, and then so what's the conclusion? The conclusion would be that critical thinking can be taught. So notice that this is an inductive argument. It pulls together a bunch of claims and pieces of information and then summarizes them with a statement or theory. Inductive arguments will rarely be laid out like this, where it will say premise 1, premise 2, premise 3, etc. But instead, usually you'll have a couple of sentences describing a study or a piece of evidence in a paper, and you'll just have to figure out, okay, what can we conclude from all this information? The first thing I want to talk about are some factors to consider when evaluating a claim or theory through inductive reasoning. Remember, with deductive arguments, you just have to care about the form of the argument, is it valid, and the soundness of the premises, are they true? If so, you're done. But you can't do that with inductive reasoning. Instead, these are some factors to keep in mind when considering whether to accept an inductive argument or to decide how good an inductive argument is, or whether a theory or claim has enough support for us to accept it. The first factor is the quality and quantity of the supporting evidence. So you want to know how much evidence is there and what type of evidence is used. Think back to our discussion of the 5 types of evidence from a couple of weeks ago and our discussion last week of the different types of research methods used in psychology, right? The different types of evidence differ in their quality. Referring back to our sample inductive argument about the teaching of critical thinking, we cited 6 or so good scholarly articles that use traditional research methods supporting the claim that critical thinking skills can be taught. And so we have to decide, is that sufficient good evidence for us to accept that claim? The second factor to consider is the quality of the source of evidence and whether it's a primary source or a secondary source. So first of all, I hope we can appreciate that the source of the evidence matters. That evidence that comes from a scholarly article or book is generally going to be of higher quality than evidence that comes from Wikipedia or Twitter. Beyond that, there are 2 general sources of information. A primary source is the original source where a piece of information is described. So I'm sure many of you have had to write a paper in APA style, and those of you who have know that in the introduction is where you describe other research that has been conducted on the topic that you're writing about. The original articles that you find to talk about in your introduction, those would be primary sources, right? They describe evidence that has been conducted on your topic in the past. A secondary source is a source that cites, describes, or refers to a primary source. So your introduction in an APA-style paper would be a secondary source, because in your introduction, you are describing the original source, you're describing the primary sources. Or think of it this way. Your friend might witness some event, for instance, a crime. Let's say he or she can accurately describe what happened to you. You then might tell the story to another person. Your friend's account would be the primary source because he or she is the one that witnessed the event, and your telling of the story would be a secondary source because you are describing your friend's experience. So, what do you think would be more accurate? Your friend's description of what happened or your description of your friend's account of what happened? Well, presumably your friend's description, the primary source, is going to be more accurate. So overall then, primary sources are preferred because sometimes secondary sources incorrectly describe primary sources. So if a secondary source makes an error in terms of describing the primary source, using evidence from that secondary source would constitute poor quality evidence. That is, when you consult a secondary source instead of the primary source, the quality of the evidence depends on the quality of the secondary source. You're relying on someone else's interpretation, which may or may not be accurate. The third factor to consider is whether all or most of the evidence has been considered. So you want to make sure that someone isn't only selectively presenting evidence that supports their theory and ignoring contradictory evidence. You want to watch out for confirmation bias. You want to make sure that you're being presented with all evidence so you can determine whether the claim is actually supported, or, like I said, if someone's just feeding you evidence that supports the claim and is ignoring or not presenting you with the relevant contradictory evidence. The fourth factor to consider is that the conclusion of an inductive argument may be true even when not all of the evidence supports it. Think back to our example of the ability to teach critical thinking skills. Some pieces of evidence support the notion that it can be taught, while others suggested that it couldn't be taught. However, because most of the information supported the claim that it could be taught, that's what our conclusion was. So the point here is that just because there is some evidence against a theory or claim, it doesn't necessarily mean that it is false. That being said, it is still important to consider why there's contradictory evidence. We still want to know why some studies found no improvement in teaching critical thinking skills. Maybe it's because those studies or programs didn't last long enough. And obviously, if there's enough contradictory evidence, then you might seriously doubt the claim. But overall, a couple pieces of contradictory evidence shouldn't prevent us from accepting an otherwise well-supported claim. Now, for this reason, inductive arguments are never proven. Instead, one speaks in terms of current support or lack of support for them. So because the conclusion of an inductive argument depends on the relevant quality and quantity of the evidence, which is always changing in science, we speak of inductive arguments or theories as having a certain degree or amount of support, not in terms of being proven. That is, the evidence for an inductive argument may be more or less strong, but it never proves that a theory or conclusion is true. Just think of all the theories that were thought to be true or proven at some point in time. The Earth is flat, the Earth is at the center of the solar system, people get sick because of evil spirits, people only use 10% of their brain, etc. This doesn't mean that all theories are equal. Some theories do have more support than others, and those should be more generally accepted as true. So the theory that people experience ESP or extrasensory perception is not as well as accepted as a theory that depression is caused by a depletion of the monoamine neurotransmitters, for instance, norepinephrine, dopamine, and serotonin. The theory of gravity is much more accepted than the theory of past lives. So while it may be true that the Earth is flat, the best supported theory is that it's round, and someone who says, well, your theory hasn't been proven, so you must accept my theory as well, doesn't understand how science or theories work. And finally, some things to consider when generalizing from a sample to a population. This is what we do in research all the time, right? We take a sample of participants, and we use the results from our sample to say something about the population. And remember, this is also how inductive reasoning works. We make a few observations, and we try to generalize from those observations to make a general conclusion. So there are two things you want to make sure of when generalizing from a sample to a population. That is, for the conclusions you draw about the sample to also apply to the population. First, you want the sample size to be large enough. We might take a sample of 4 Frostburg State University students and ask them their political party affiliation, finding that 3 of them plan to vote Democrat. Well, is it fair to say from this result that 75% of Frostburg State University students, or 75% of college students in general, plan to vote Democrat? Well, probably not. Our sample size is too small. Or you might buy a used Chevy, have it break down after 5,000 miles, and conclude that all used Chevrolets are bad cars. Is that a fair conclusion? No, your sample size is too small. Or someone might say, well, my dad has smoked a pack of cigarettes a day for 40 years and is extremely healthy. So all this talk about the hazards of cigarette smoking is overblown. Is that a fair conclusion? No, the same issue, you only have a small sample size. It's not large enough. The second thing you want to make sure of when generalizing from a sample to a population is that the sample is also representative of the population, meaning that it has the same characteristics of the population. So samples must not only be the right size, but they also must be like the population we want to say something about. If we want to know what Frostburg State University students think about the university, we shouldn't just ask incoming freshmen because the views of sophomores and juniors will probably be different. So we want to ask undergraduates of all 4 years. Same thing with other characteristics like age, sex, socioeconomic status. We want to make sure that the characteristics of the sample are similar to the characteristics of the population. In fact, even if your sample size is huge, if your sample isn't representative, your conclusion about the population based on the sample may be wrong. For instance, in 1936, the Literary Digest magazine conducted a poll to try to predict the outcome of the 1936 presidential election. They sent out 10 million ballots to their subscribers, people selected from phone books, and people selected from motor vehicle registration information. Around 25%, or 2.5 million of the responses were returned, and 57% favored Alf Landon, the Republican candidate, while only 40% favored the incumbent president, Franklin Roosevelt. Well, has anybody ever heard of President Alf Landon? Probably not. So that gives you an idea about who actually won. In the actual election, Roosevelt won by a landslide with 62% of the votes to Landon's 37%. So the question is, can you see why the results were so inaccurate? Why the results of the sample turned out nothing like the results of the population? Well, it was because the sample wasn't representative of the population. Most of the magazine's readers were upper middle class Republicans, but they thought they'd broaden their sample by choosing people from the phone book and car registration logs. However, in 1936, in the middle of the Great Depression, the majority of the people who owned phones and cars were upper middle class too, who tended to vote Republican. So their sample, even though it was large, wasn't representative of the U.S. population. It had too many wealthy people, and so their conclusion was wrong. In the actual election, Landon only received 8 electoral votes, tied for the fewest for a major party candidate, and this mistake led Literary Digest magazine to exclaim, understandably, "Boy, is our face red." The last big topic for today's PowerPoint is going to be different types of faulty premises. These types of statements and arguments I'm going to describe momentarily might sound like good reasons to believe a claim, but they really aren't. And so, if they are used as part of an inductive argument, that premise or piece of evidence should be ignored. You can also think of them as logical fallacies. The first type of faulty premise is weasel words, using qualifying words to make a seemingly strong claim based on accurate but weak evidence. Weasel words give you an out if you are challenged. They allow you to say something that is technically correct or accurate, but if you look closely at the statement, you'll realize that the weasel words make it weak. Some examples of weasel words are words like some, debate, help, and might, words like that. Here's an example. Because there is still a scientific debate about climate change, we shouldn't spend money to try to prevent it. The weasel word here is debate. This word makes the statement technically true that yes, there is technically debate and not a consensus among scientists about the validity of global warming, but if you think about it, this is a pretty weak argument. Of course, there is a debate about global warming. The scientific method, as we discussed this week, is based on constant debate, where theories are continuously being tested and updated when new evidence comes along. Moreover, while there might be a debate, it is pretty one-sided.
with something like 5% of climate scientists saying that there is no man-made global warming, while 95% of climate scientists say there is. So the key point is that the weasel word debate makes this statement technically correct, but in reality it's a normal aspect of science and is minor at best, and thus this statement is, again, accurate but weak. You also see weasel words used a lot in advertising, especially with dietary supplements. There are laws about what drugs that are not regulated by the FDA, like dietary supplements, are allowed to claim. For instance, they can't claim that they can cure, treat, or prevent disease, but they can claim to fight or support something like heart health or kidney function. Or in this case, they can claim to help support healthy blood pressure or formulated for whole body healthy inflammation response, whatever that means. So the point here is that it sounds like these products are saying that they can treat your high blood pressure or they can cure your inflammation, when really that's not what they're claiming to be able to do, because, well, they can't. The next type of faulty premise is a false dilemma, which is proposing that only two alternatives exist, with one usually being clearly unacceptable when there are really more than two. So you're asked to decide between two options, but one of them is clearly undesirable, so really there's only one logical option. But the point is that with the false dilemma, there are way more than these just two options that you're being presented with. You hear false dilemmas a lot in politics. For instance, when talking about military operations in Iraq, President Bush once said, either you're with us or you are with the terrorists. Well, this is a false dilemma. He's saying that there are only two options. You are with us when we go to war with Iraq, or you are a terrorist, when clearly there are other options, right? You can certainly be against terrorists as well as military involvement in Iraq. Here's another example. Either you have your horoscope charted by an astrologer, or you continue to stumble through life without knowing where you are going. So here are your only two options, and clearly you don't want to go through life without knowing your direction, so what's the only logical thing to do? To see an astrologer. Well, no, this is a false dilemma. There are way more than just these two options. So if someone is concerned about the direction their life is taking, they can speak with their friends, speak with their family members, or even see a licensed therapist. Next, we have appeal to ignorance, arguing that unless a claim has been shown to be false, it must be true. The key point to keep in mind with this one is that the belief in an inductive argument should be based on the amount and quality of evidence to support that argument, not the lack of evidence against it. For example, if you want me to believe the claim that playing violent video games is associated with aggression, that's fine, but you need to provide me with evidence that there is a relationship. You can't say, no one has been able to show that violent video games doesn't cause aggression, so therefore you must believe that they do. You can't use the lack of evidence against something as evidence that it exists. That would be an appeal to ignorance. Here's another example. Until you can demonstrate that Bigfoot doesn't exist, you must believe he is real. Again, this is just not how inductive arguments work. If you want me to believe in Bigfoot, that's fine, but it's up to you to present me with evidence that Bigfoot exists. You can't use my inability to prove that Bigfoot doesn't exist as evidence that he does. If you claim that the moon is made of cheese and I can't disprove it, that doesn't make you right. The burden is on you to present evidence that the moon is made of cheese, not for me to present evidence that it isn't. Next, we have an ad hominem premise, rebutting an argument by attacking the argument's presenter rather than the premises themselves. Ad hominem means to the man, so instead of attacking the argument, the person is criticizing the person making the argument in hopes of discrediting the argument. For instance, Stephen works for the NRA. If someone works for the NRA, then you can't believe his statistics about gun safety. Therefore, you can't believe Stephen. Right? Stephen works for the NRA, so of course he's going to lie. The issue is that a premise stands or falls on its own merits. Who proposes it is irrelevant to its soundness or accuracy. The data either show that gun safety is increasing or they don't. Who tells you about the data is irrelevant. Here's another one. Those who criticize astrology are often cold-hearted scientists who are closed to deeper human potential. Now, even if that is true, which it probably isn't, it's completely irrelevant to whether astrology is true or not. What matters is the validity of the criticisms, not who makes them.
So if we have valid criticisms against astrology, it doesn't matter if we're cold-hearted. What matters is that we have valid criticisms against astrology. I don't believe in global warming, do you? Says Anders Breivik, a mass killer. I guess the argument is that this person doesn't believe in global warming and is a deviant, so unless you're a deviant, you should believe in global warming. I guess the argument is, it sort of makes my head hurt, but the idea is that instead of criticizing, the facts about global warming, we're attacking the person making the statement, and that's just wrong. And then the last faulty premise is the straw man premise, misrepresenting someone's claim to make it easier to argue against. The term straw man comes from military training, where soldiers began by practicing combat skills against a dummy stuffed with straw. It was very easy to attack, but it certainly wasn't like the real thing. Applied to arguments, then, instead of addressing the actual claim presented, you concoct a weak claim to assault, a straw claim, if you will, that's easy to knock down, but isn't the real argument or claim. So, for example, suppose a senator proposed a hypothetical bill that would ease gun regulation by shortening waiting periods from 2 weeks to 3 days. Someone might argue his bill lessens gun control, so clearly he wants children to own guns. Children shouldn't own guns, therefore you should vote against his bill. The problem is that this argument distorts the senator's position, right? He wants the waiting period to be reduced by a little, not for children to have access to guns. You're misrepresenting his bill, his claim, to make it easier to argue against. You might remember Senator James Inhofe throwing a snowball in the Senate a couple years ago to argue against global warming. Basically, he was saying something like, scientists say there's global warming, but it still snows in February, doesn't it? Therefore, the theory of global warming is false. Well, the theory of global warming doesn't mean that it would never snow in February anymore. It just means that the temperature of the planet is increasing. So you're misrepresenting what the claim of global warming is if you're saying that the fact that it snows in February argues against it. Anyway, that's it for me.